You got it? Okay. Let's begin with a word of prayer. Dear Heavenly Father, we thank you again for this opportunity we have just to meet together and just study your creation. Just pray be with these students. Help us to just wrap up our thinking on the material before test 1 for their homework, which is due Saturday. Just thank you, Lord, for your many blessings. We thank you, Lord, that you love us each and every day, even if we don't love you, Lord. We thank you for your grace and mercy for us this day. Just ask you to just bless this class, Lord. In your name I pray. Amen. So, guys, questions? I'll take yours next. Yes?
Okay. Can this be on kind of like questions?
Yeah, you can ask more questions, sure.
Number 5 on section 3.
Homework 3, number 5.
I don't get like the A and B kind of thing.
So, homework number 5 in... Uh-oh. I gotta get a marker. Otherwise, it's gonna be hard. Oh no. What? Oh, okay. Good. So here it's you remember we had the problem before where we had to find a constant to make the function continuous, right? Well, now it's kind of like that. So tell you what, I'm going to do a problem which is similar to your problem, but not quite the same. So let's suppose it's x cubed and ax plus b. And so x cubed if x is less than or equal to 1, and it's ax plus b if x is greater than 1. So this is a piecewise defined function. All right. And our problem is to find the values of a and b so that f is continuous and has a derivative at x equals to 1. And then they give you options for the sketch of the graph, none of which will be the sketch of our function, obviously, because I changed the problem. So, you guys, what would this generically look like? Like, just before we even do any formal calculations, do you know how to graph what's going on here? What are we doing? So we've got a cubic, right? Y equals x cubed. Looks something like this. That's a standard cubic. It does something like this, right? And then we've got a line. So a line would be like this, generally speaking. And what we're trying to do is to choose an A and a B so that these graphs, first of all, paste together so it's continuous. And second of all, they paste together so that the slope of the cubic matches with the slope of the line so that it actually has a derivative at 1, right? So basically I want to adjust the slope and the y-intercept so that my graph kind of looks like this. This is a line, right? So how do you go about this? First of all, let's deal with the issue of continuity. So we're trying to find A and B to make f continuous and differentiable. What is to say a function is differentiable? What's that mean? It means it has a derivative. You mean to tell me that not all functions have derivatives? Indeed, I do. But I'll do that next. Let's focus on this here. Continuity. Continuity is clear everywhere except for one place, right? Focus on what? X equals to 1, right? So we need to look at the left limit and the right limit. They should be equal, right? So the limit as x approaches 1 from the left of f of x is equal to what? Well, that's equal to the limit as x approaches 1 from the left of x cubed. Likewise, let's see here. What's the limit from the right? If you look at the right limit, we use the other case, right? Because the right limit considers values of the function to the right of the limiting value, which means we're in the second case. We're in the case that the function's values are given by ax plus b. So guys, can you tell me what these limits are? Fill in the blank for me here, huh? One, right? And a plus b, right? X is equal to 1, so you just plug in 1 and a plus b. We can do that because it makes sense, right? If I had done this and I got division by 0, then I'd have to do more calculation or whatever. So these have to be equal, right? So 1 is equal to a plus b for continuity at 1, right? Does that make sense? Now, that doesn't tell me what a or b is, but at least it gives me an equation, a nice, simple, linear equation I can use. All right? So what's next? Well, I don't have enough. I've got one equation and 2 unknowns. I can't solve for them yet. I mean, I could solve for b or something, but how about this? That was just continuity. What's the other thing we have to worry about? Yep, differentiable. So we have to have the f prime of 1, which is what? The limit as x approaches 1 of what? F of 1 plus h minus f of 1. Oh, I'm sorry, guys. I'll do it this way. Well, I don't want to do it that way. If you guys don't mind. Oh, fine. There's an easier way than to actually do this limit. But anyway, so in order for this two-sided limits, what do we have to have, both sides? Yeah, the same slope. They both have to exist and equal this, right? So I need the limit as x approaches 1 from the... Oh, I'm sorry. It should be x approaches 1 here. I'm sorry, what's it? No, it's not an x limit at all, is it? If I use h, what should I have here? Yeah, h goes to 0, right? 1 plus h minus f of 1 divided by h, that's the derivative at 1 in terms of the h going to 0 limit. So I need the limit as h goes to 0 from the left of f of 1 plus h minus f of 1 divided by h. And I need the limit as h goes to 0 from the right of that thing. Now, what's f of 1? What's f of 1 plus h? Depends on which case we're in, right? The top case where h is negative, right? So 1 plus h is actually a little bit less than 1, which means we're in which case? We're in the x cubed case, right? So this one would be 1 plus h quantity cubed minus 1 all divided by h. And this one, we're in the limit as h goes to 0 from the right, h is positive, so we're not, f of 1 plus h is governed by the second case, so we'd have a times what? 1 plus h plus b minus what? Minus 1, right? F of 1 is 1. I'm setting x equal to 1 plus h. So it's the difference quotient. Now this is kind of a drag, but it's not too bad. If you cube this out, what do you get? You get 1 plus 3h squared plus 3h plus h cubed minus 1 all divided by h. The 1's cancel. Oh, did you get that? Okay.
Where did, why did the 3h squared plus 3h plus h cubed go to, so you, wait, so when you divide by h, you can take an h out from each one of those?
Yeah, the ones cancel, and then I can factor an h out.
That makes sense.
Of course, what's the answer there to the top? It's just what? 3. And this one, if we simplify this further, what do we have? We've got a plus b plus ah minus 1 divided by h. Just multiplying out. Yeah.
In the second one, why does f of 1 equal 4?
Oh, we learned that back here. The function's continuous, so.
I thought we were taking all from a plus b.
I mean, f of 1 is 1 back from here. We're assuming continuity.
Bring the 1 into the ax plus b.
Well, the f of 1 is in the less than or equal to case here. So if I plug in f of 1, it's 1 cubed, but 1 cubed is 1. Now, I think you're about to tell me that f of 1 is a plus b. Is that what you're going to tell me?
Yeah.
I can't really argue with you because those are equal. See? 1 is equal to a plus b. So we're really not on different pages. It's just a question of logical priority. The definition is, it's fine. But you're right, 1 is equal to a plus b, so what happens with this expression? And the a plus b and the 1, these cancel, right? This and this, they because 1 is equal to a plus b, so a plus b minus 1 is just 0. And we get what? We get, now look at this. This is really totally unsurprising what we're about to derive, because what is the derivative? It is the slope of the graph, at the point of tangent line. What's the slope of a line at any point along the line? It's just the slope of the line. It's got a constant derivative. And so, yeah, the h's cancel out, and you just get a.
I get that you could pull it out because it's kind of the same thing. Up there, a plus b and the negative 1. But does it matter that it's negative 1 and not 1?
But this means that a.
Yeah, okay, I get you.
Oh, okay.
Yeah. Why does it?
Because of continuity, the right and left limits of the function, they have to glue together. Yeah.
Can we just do a shortcut? Because when I was doing it on with the textbook, it just said that you can do the derivative of x cubed, which is 3x squared, and then make that equal.
Indeed, that was that was the thing I was grumbling about once I wrote this down. This is just logically what you should do. You should show that the derivative exists, which means the left and the right limits exist. But there's a trick here, because on the let's see here. In here, on this whole place, we have f prime of x by the power rule is 3x squared, right? And I have that it's 3x squared all along this, all the way up until 1, right? So, in other words, the derivative as you approach, the slope as you approach 1 from the left ought to just be the value of this thing as x approaches 1 from the left. And of course, that gives us 3. And that's fine. Yeah, you can do it that way.
Are we allowed to do it that way on the test?
Yeah, of course. No, on the test that would be fine, as long as you, say something. I mean, there should be a sentence. So replace this blah 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 with, since f prime of x is equal to 3x is equal to, the derivative with respect to x of x cubed, which is equal to 3x squared for x less than 1. This suggests the slope of y equals f of x from the left should be, 3x, well, should be 3, since the limit as x approaches 1 from the left of 3x squared is equal to 3. So there should be some kind of sentence, but something. I mean, you don't have to use exactly my words, but something to communicate, hey, I'm using the 3x squared because that's the derivative on over there, so it has to piece together with the derivative on the right, and they have to match up. Yes, sir?
For the limit, like the derivative definition over there, it says where f of 1, how do we know that that's minus 1? Like, we're substituting between like the green line and the first.
F of 1 is equal to 1 because it's right here, x less than or equal to 1, so f of 1 cubed is 1. Yeah. Before any more questions, let me finish the thought here. So we've shown that the derivative from the left is 3, and the derivative from the right is a. They have to match up if the derivative is existing, right? So you can talk about the notion of a left tangent and a right tangent. And so the derivative only exists if the left and right tangents both separately exist and match the slopes of those tangents, right? So, the left tangent here is 3. The right tangent here is a. Slope of the tangent, of course. And so what do we get? So we find that 3 is equal to a from that stuff, right? And so then what do we got? What's b equal to? 1 minus a, right? Which is minus 2, right? So therefore the answer is f of x for the one I made up. You got x cubed if x is less than or equal to 1. We had no freedom over that, but the a and the b, we've got, let's see here, 3x minus 2 for x greater than 1. And there you go. That piecewise defined function is everywhere continuous and everywhere differentiable because we made the slope of the tangent on the different pieces match up. Is there any other question about this problem?
What is 3 equal to?
Because the left tangent and the right tangent have to match. Here, let me show you an example of a function which doesn't have matching left and right tangents. So here's the standard example of a function which is continuous but not differentiable. So if I look at the absolute value of x, right? What's the graph of the absolute value of x look like? It's y equals x over here. It's y is equal to minus x over there, and they match. They both meet at the origin, right? So what would the left and right tangents be there? The left tangent would be just like this, right? So you could think of it as an arrow like this. Left tangent has slope what? -1. On the other hand, the right tangent, coming from the right, extending the right behavior of the function, it has slope 1, right? Because it's the extension of this line of slope 1. As you can see, those don't match, and that is why f prime of 0 does not exist. There is no well-defined tangent line at that corner in the graph. So one of the ways we can fail to have a tangent line is if we have like a crease in the graph, a kink or a corner. You won't have a tangent line there. Because you might have two and you can't decide which one it is you should use, basically. Well, the graph doesn't, it is continuous. Both the left and the right limits piece together, right? You can draw that, you can watch me, see? I can draw this, I can draw it without lifting my pen. You know, it's continuous in the sense we talked about before. The left and right limits exist, right? But the tangent line, there's no tangent line at that point because it's jagged. Do you have a question in the back?
You just answered it.
Oh, okay. Yeah.
I'm just used for the second part, the H0 to the right.
Mm-hmm.
Like the second part of that, how'd you get from that to like the third? That gets the next one.
From here to here, what I did was I multiplied a times 1 gives me a, and a times h gives me ah, and I put the b, I switched the order of the b and the a times h term because I wanted the a and b to be together for my cancellation.
And then how'd you get just A as like the?
Over here,
Yeah.
it's because a plus b is equal to 1, so a plus b minus 1 is 0.
That's in the over there, right?
Yeah, that we knew from continuity.
I just got really confused,
No,
sorry.
it's okay. I mean, that's the thing that makes this problem harder than your other problems, is it's got 2 equations and 2 unknowns in it. You know, it's a little bit more algebraically involved. There are other ways the tangent line might not exist. Another way that a tangent line might not exist is if you had a discontinuity. Like even if this slope matched that slope, the fact that there was a jump in the graph, that would mean we would say that the tangent line doesn't exist there either. Yep.
What's the significance of the plan that the small circle? You just filled in one so that
Oh, right. Well, the convention is that if the circle is filled in, that's actually a value on the graph. So if this was, say, 4, and this was the y-axis, and this was, say, 1, filling in that dot would tell me if this is the graph y equals f of x, that would tell me, in fact, that f of 4 is 1, right?
But you couldn't do that for the.
If this was 3, and I erased that, and filled this in, then that would tell me that f of 4 was equal to 3. And, you know, that would be... I can't fill in both dots because a function is single valued. If I filled in both dots, then the function's graph would fail the vertical line test. It wouldn't be a function anymore.
So now it like matches up with continuity and everything. It's fine, right?
My jumping graph?
Yeah.
No, that's not continuous.
All right.
Yeah.
How come that can jump but that can't?
How come that one?
Yeah.
Well, here, so there I haven't given, well, if it was a variable line, if I had given us the freedom to adjust where this line meets the other one, that'd be yeah, I could.
So that one can move, but that one wasn't able to.
Exactly. We have parameters A and B that we have the freedom to choose in order to make the graphs sync up. That's the difference.
So because that's not a piecewise.
Well, they're both piecewise, but the difference is, technically speaking, that's a family of piecewise functions where each choice of A and B gives you a different function. That over there is just a graph I drew. There's no like A and B to adjust. It's almost a philosophical question we're getting into here. Like, why can't you adjust the graph over here? I guess I could, and then we would agree that they're the same thing, you know? Someone ask me another question before I dig this hole deeper. Thank you.
For homework 3,
Uh-huh.
1, the tangent line, the fact that the tangent line at the point -1, -1 or 9, I'm confused about how you get an x beyond the point. Because I have the f of a and the f of a, but how do you get x minus 5?
Oh, let me erase this before somebody else asks another question about it. It's good that we spent time on this example. It takes, I think this is probably the hardest problem in your homework, right? This one?
Which one was it?
Problem 5 is, which, are you talking about the one she asked about or the one I'm erasing?
Yeah, the one you were raising.
It's number 5. Homework 3, number 5. Yeah, true. I didn't work exactly the problem. Okay. I will be boring and just work the homework problem if you don't mind. F of x is equal to 1 over Give me a second here, and then I'll get up to speed with your question. F of x is equal to 1 over x minus 4. Part x minus 8. Yeah. You asked the question. I'll put 8 there for you. No problem. And but then you're going to have to tell me the rest of the question. So first of all, find f prime of x. There are two ways you could find f prime of x now. Did it tell you to use the definition of the derivative? Aha! So we don't have to use the definition of the derivative if we don't want to. So how can we differentiate this? This is d dx of f of x over g of x, where f of x and g of x are what? Oh, bad choice of letters. Sorry, I'm going to have to get more inventive with my alphabet here. How about h and g? So what would, chain rule says h prime g minus hg prime divided by g squared, right? And here I'm envisioning h of x equals to 1, and g of x, the denominator function, x minus 8. I can view this as a quotient rule problem, and I can just differentiate it. And what does that give me? What's the derivative of 1? 0. All right. So that first term is 0 times something that's not 0, but who cares? It's 0 times whatever. It's still 0. 0 minus h. Well, h is 1. 1 times what? G prime. What's a g prime? What's the derivative of x minus 8? Yep. Uno. So 1 again. And then I divide by x minus 8 quantity squared. Aha, so there you have it. Minus 1 over x minus 8 quantity squared is the derivative. There's how to do it with the quotient rule. What if some mean calculus instructor said, find the derivative using the definition? How would you do it then? Tell you what, I'll save that for when we're done with the problem. I'll finish the problem like this, and then I'll go make our life less pleasant at the end, okay? So there's your derivative. What's the next part of the question?
It says find an equation of the tangent line to the curve at the points -1, -1 over 9.
Find equation of the tangent line at, what you said it was what, negative? Or
-1,
negative 1,
then -1 over 9.
negative 1 over 9. Okay. So what was the question? So that's fine?
Yeah, that's
Okay.
it.
So, what we do, as I told you guys, if you want to write down the equation of the tangent line, you say y is equal to f of minus 1 plus f prime of minus 1 times x minus a minus 1. What's x minus minus 1? It's just x plus 1. And so that will give me a line through the point minus 1 comma f of minus 1 with slope what? F prime of minus 1. That's my template. That's what I need. That will give me the equation I'm looking for. The question then is, what are those quantities? Now, f of minus 1 is already given to you. See, because if they ask you for this, the tangent line at this point has to be of the form a comma f of a, if it's on the graph. So I can already look at this and tell you that f of minus 1 is minus 1/9 without even doing any more calculations. I can tell you that. But how else could we find f of minus 1? You could just plug minus 1 into your formula, right? So minus 1 minus 8 is minus 9. So minus 1 over minus 9 is minus 1/9. What's f prime of minus 1? Yeah, minus 1. So minus 1 over minus 1 minus 8 quantity squared times x plus 1. And so just to clean it up, that's minus 1/9 minus 1/81 times x plus 1. And so, at least on my test, that is a perfectly welcome answer. Now, if you want me to put it into mx plus b form, we can multiply it out and do that, but there's no need. I mean, that's the equation of the tangent line right there. Was there a part C?
Yeah. It just says sketch the graph of that and the tangent line.
Oh, okay. Woot, woot. Where was it? -1. So roughly speaking here's your point of tangency. And tangent line, something like the slope is shallow and negative. -181st. It's nearly horizontal, right? As you can kind of see from my poor sketch of this, here's your tangent line. So there you go. Something like that. How did I know how to graph 1 over x minus 8? I've had math courses before, is the answer. This is a reciprocal function, right? Here's how I think of it. I think of it y is equal to 1 over x, but then I'm changing it to 1 over x minus 8. What did I do? I replaced x with x minus 8. So that means I take the graph, the reciprocal function graph, and I do what? I shift 8 to the right. Remember that? Transformations graphs. And that is how I got here. Or if you don't remember transformations of graphs, you can just look at the formula and kind of just see it. X equals to 8. I have division by 0. It's huge, huge. And, sorry, there's a little 2016 presidential humor for you there. And then so it goes down to infinity, minus infinity, and goes up to infinity. You can see that by just plugging in values to the right or to the left of the vertical asymptote to see which one's going to plus infinity, which one's going to minus infinity. I don't know. Graphing is still something you need to know how to do. And it's probably your principal weakness. Most people. What did I say before about that?
You said no graphing calculators.
I said no graphing calculators? Oh, I said it's allowed, but I don't encourage it. Yeah.
Graphing?
Yeah. I mean, you can use a graphing calculator if you want, but I will ask you to solve problems in such a way that it doesn't rely on it. It might help you to have it, but it shouldn't hurt you not to, is what I'm trying to say. Yeah. Yeah, of course.
I got one for you. So if you polynomial divided by x and the function time is limited, I don't know what number it is, but either the polynomial.
Oh, you just tell me the formula? That'll work.
Yeah. Here is the pass from.
Oh. By courier. All right, so I refuse to do this by the limit.
Yeah.
Oh, I still owe you guys the limit calculation for the previous example. You guys distracted me. So, oh, okay. Well, I mean, if you guys are all good with the limit calculation, then I won't spend any more time on it. I mean, I'll finish this and then I'll go back to the definition. Do remind me, otherwise thanks. Okay, so this one, there's a right way and a wrong way to do this problem. Well, there's two wrong ways. The first wrong way is to try to do it with the limit definition. Don't worry, I'm not so malevolent that I would ask you to do that. That would be unpleasant. The second wrong way is to use the quotient rule. No, not quotient rule. The way you should do it is to use algebra to simplify the expression before you differentiate. So this is 8x cubed divided by x plus 5x squared divided by x plus 6x divided by x minus 9 divided by x. Let's see here. And so what is that? 8x squared plus 5x plus 6 minus 9x to the minus 1 power.
Oh.
And then I just do power rule, power rule, power rule. It's a constant, so it's 0. Power rule. Yes, sir? Oh, sorry.
I used the power rule and it didn't work.
I was using sir in the peanuts sense of the term, but what's that?
I used the power rule for that problem and it didn't work.
Oh?
I did that exact same thing.
Oh?
I got the minus.
Oh.
I checked it in.
Okay. Well, I don't know. 16. Yeah, keep going. Thank you. 16 plus 5. Plus 9x to the minus 2. Oh. 6 is no changing. It is.
Oh, yeah. Okay, so it disappears.
Yeah, its derivative is death to constants. Which problem is this? I mean, there may be other. 4 of homework 4.
Okay, I was going to say you're on number 4.
Uno momento.
This
Yeah, well,
Why did that do Saturday? Homework 4 is due Saturday.
they're all due Saturday.
It is.
That's what, I mean, that is analogous to the answer I have in the corresponding homework 4, number 4. Maybe there's a sign error. Maybe you like switch to plus to a minus or something like silly. Because if that's most of what you did, you're mostly right. There's no like special instructions like rewrite in terms of positive exponents or anything like that, so that should be fine.
How does the negative 9 become a positive 9?
Ah, now there it is, right there. So that's the power rule. N equals minus 1. So we have d dx of x to the minus 1 is minus 1 times x to the minus 1, which is minus x to the minus 2. That minus cancels with the existing minus to give me plus.
Okay, I think that's what it is.
Yay! All right, we found it. So that was I'm glad that you found it. That was my suspicion. Here, let me go back and do the definition derivative here before I forget and we get further away from it. How would you calculate the derivative from the definition for part A here? F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x divided by h.
Excuse me.
What did I do?
No, I just no. I'm good.
Oh,
Thank you.
okay. Very good. So limit as h goes to 0, and then what is the f we're doing? The function was here. It's 1 over x minus 8. So I have to take x and I replace it with x plus h, right? So I have 1 over x plus h minus 8 minus 1 over x minus 8 quantity, all divided by h. And of course, this is a derivative, so it has form 0 over 0 to start with, and we have to do algebra to reduce the indeterminacy of the limit, just like every other one that we actually calculated. And it worked out. So what do you do? I like to bring the 1 over h out front and just write it as 1 over h times a big thing. Okay. And so we just cross multiply, make a common denominator. So what do I have here? I'll do the denominator, the easy part. X plus h minus 8 times x minus 8. What goes upstairs? Right, x minus 8 minus, and then parentheses, okay? X plus h minus 8. Things be canceling. 8's cancel, x's cancel. what's left? H. Actually, a minus h. Do you agree? I mean, you see the x's cancel, the 8's cancel. You're just left with an h. Yeah, negative h, sorry. And then they reduce, right? Those cancel out, leave you a minus 1, right? And so we end up with, so these cancel basically. And we're left with 1, or rather minus 1 over x plus 0 minus 8 times x minus 8, which of course is just what we found before with the quotient rule, minus 1 over x minus 8 quantity squared. Of course, if you are comfortable and confident about the quotient rule, that's way easier. And if you happen to know the chain rule from high school, that's easier still. But I don't expect you know that, and you won't need to know it for the test, all right? Yeah.
How does the h cancel out in front of the x plus h minus 8? We lose nothing again.
Well, because if I have 1 over a times b times c, it's equal to 1 over a times 1 over b times c. And so, but I also have basically like an a upstairs, right? So you can just take the a out here and then they cancel. So think of a as being like the h. So I have h appearing up here, h appearing down here multiplicatively. They're both factored. They just, that's, yeah. It's kind of a boring answer to give, but algebra. It's like, it's kind of the Sunday school answer. It's like, what made this happen? God. It is always true. No Sunday school teacher can argue with it almost without exception. Sometimes without exception, depending on their particular brand of theology. But Calvinists are easier. Yes. Oh, whoa, whoa, whoa. Then I'll speak up at once. Oh, we got one up here? Okay, go for it.
All right, number 7 on 4.
Number 7 on 4. Exciting. Find the slope and equation of the tangent line, the graph of the function f at the specified point. So here we have a quadratic, which is kind of boring, but I'll take it. Okay, so here's the function f of x minus 3/2 x squared plus 6x plus 6. And then we're supposed to find the tangent line at minus 1 minus 3/2. It's so nice that they always tell you the y thing for the tangent line. They don't really need to do that. So you're supposed to find slope and equation for the tangent line at minus 1 comma minus 3/2 for y equals f of x, right? So this is homework for number 7, right? Which, by the way, corresponds to problem 42 in section 3.1 of your book. You know that? This little number here means that, 3.1.042. That means this corresponds to problem 42 of section 3.1 in the textbook. Which means if you want to look at other similar problems, you can go look at that. If the WebAssign isn't enough, there are more problems in the book. I know most of you are like, it's okay, I'm good. But let's see here. So, first of all, we calculate the derivative. What's f prime of x? What should we use here? Definition? Not unless someone makes us, right? So power rule. So we got minus 3 d dx of minus 3 halves x squared plus d dx of 6x plus d dx of 6. There, I'm just writing out the thinking for you. You don't have to write this, right? I mean, I personally am totally fine with you going straight to the next thing I'm writing in red, which is what? Negative 3x. What happened to the 2? Right, yeah, the 2 and the half canceled. And then the derivative of 6x, well, the slope of the y equals 6x minus 6, so that's 6. And of course, constant be dead. So there you go, there's the derivative. Function, what's the slope of the tangent line at the point we're interested in? F prime of minus 1 is equal to what? Minus 3 times minus 1 plus 6, which is 9. There you go, that's the slope of the tangent line. That's the slope of the tangent line at the point in question. And then what's the equation of the tangent line? Again, I'm going to be lazy and use my go-to formula. Y is equal to f of minus 1 plus f prime of minus 1 times x plus 1. And I know everything there. I just plug it in. What's f of minus 1? It was given to you implicitly at the start. Negative 3 halves, right. That's the y coordinate of the point of tangency. And then f of minus 1 is 9, and x plus 1 is its own self. There you go. So there's the equation of the tangent line. Behold. It's kind of cool, though. That's the best linear approximation to that quadratic near that point. I will resist my natural inclination to try to graph this. Next. I mean, or are there questions? Sorry. I just like shouting next sometimes. It's kind of fun. Yes?
I'm having problems with average and instantaneous velocity. I thought I knew that.
Averages. All right. I'll let you just tell me the problem. Which number is it?
It's 2 of
Homework 3, number 2. And so let me see if I can find. I'll let you can give me. Sounds like you kind of half knew what's going on, so you need to. You probably it would be benefit from me working on your numbers. So which one do you have? F of x equals to what?
X squared
Minus 12x. And you're supposed to find.
the average from 4 to 4.5. From 4 to 5. And from 4 to 4.1.
4 to 4.5 from 4 to 5?
Yeah.
And what was the last one?
4 to 4.1.
What? Really?
Yeah.
Oh, that's odd. Huh. I mean, mine's the same actually, but yeah, okay.
Well, I put them in the wrong order, I think.
I mean, that's what it. Oh, yeah. I'm gonna do A is it 4 to 5?
Yeah, sorry.
It's okay. And B is 4 to 4.5. Oh, see, now it's telling a story. It's getting closer and closer to 4, right?
Yeah.
And at the end of this will be like, compare it to the instantaneous rate of change. Yes, okay, there. I knew that's what I mean. So, okay, so this is nothing, nothing to be scared of here. The average rate of change is the change in y over the change in x appropriately constructed. The change in y is just f of the endpoint minus f of the starting point divided by endpoint minus starting point. So the change in x is 5 minus 4. The change in y is f of 5 minus f of 4. I think you'll agree with me about that. The question, though, is what is f of 5 and what is f of 4? Well, f of 5 is 25 minus 12 times 5, which is 60. Minus, and then parentheses are your friend. F of 4 is 16 minus 48. 5 minus 4 is 1. Okay. The denominator was not as exciting. I don't know. What does this work out to? Something. 32 minus 32 minus plus 32. 32 plus 25 is 37, 57. I think that's minus 3. Do you guys agree or disagree? Twenty-five minus 60 is minus 35. Minus 35 minus 16 is minus 45 minus 51. Minus 51 plus 48 is minus 3. So I'm either wrong both times or right both times. I don't know. Anyway, I'm still going to say minus 3. Is that what you got?
I think I did essentially the same thing, and I got it right for the first one.
Oh. Okay. So let's look at the next one. F average, the next one, change in y over change in x again. But this time, we do f of 4.5 minus f of 4 divided by 4.5 minus 4. Now, that is actually 4.5 quantity squared minus 12 times 4.5. F of 4 is still f of 4, so it's still plus 32. This boils down to plus 32. See that? And then I divide by 0.5, which is the same as multiplying by 2. But that's as far as I'm going to be able to get without a calculator. Fortunately, I have a calculator. Let's see here. By the way, this is all you should need for the test, but again, I don't. So many of you have like an old TI-83 from high school or whatever. I want to let you use it as much as I think it's taking away from the fun of the course. Let's see here. I get minus 7 halves. AKA minus 3.5. What's up? Well, 16 minus 48 is minus 32, but then minus a minus 32 is plus 32. Yeah, because it's still subtracting f of 4. So subtracting f of 4 is just adding 32. So why not just do it again? Just being lazy. F average, again, change in y over change in x. So this time we got ourselves f of 4.1 minus f of 4 divided by 4.1 minus 4. So that is division by 0.1. Upstairs we've got 4.1 quantity squared minus 12 times 4.1 plus 32. And what do we get? I get minus 39 over 10, aka minus 3.9. I think I know what the answer to part D is going to be. It's like a preachy episode of Law and Order Special Victims Units, but in the form of a mathematical problem. I mean, it's kind of heavy-handed, I don't know. Like, okay, all right, enough already. F prime of x. 2x minus 12, right? We can use power rule. and linearity to do x squared differentiates to 2x, minus 12x differentiates to minus 12. You guys with me? So what's f prime of 4? 2 times 4 minus 12. What do you know? Minus 4. As you can see, as you take average rates of change, where the duration, the change is getting closer and closer to 0, you get closer and closer and closer to the instantaneous rate of change at 4. Let us pause and bask in the pedagogical glory of this example. Do you feel learned? Have you been educated? No? Okay.
Could you go over how's number, oh wait, we went over 3. We went over 3?
3 of which?
3 of 3.
3, 3? But that's this example again. I mean, it's the same song and dance, but
That's fine then.
I mean, there the difference is we take the change in S over the change in T, but the calculation is very much the same as this one. The difference is, of course, if you take change in S over change in T, that's average velocity, as opposed to the average rate of change of Y with respect to X. So. Uh-huh. There is something to that problem I should do, though. Let me, if you don't mind, I'm sorry to interrupt, but I don't mind doing problem number 3 of homework 3, but if you don't mind, I'd rather not do part A. So if you let me do part B and C, I'd be happy to do it. Okay? Because part A is just this again.
I get that.
You guys are fine. I said you can ask questions about homework. I didn't, say you had to ask artful questions. Let's see, homework 3, number 3, part B and C. Okay, so we have S of t, which is the position at time t of some ball, I guess, 96t, minus 16t squared. Yeah, this is in feet per second. 32 feet per second squared is the is gravity in feet and seconds. All right, so yeah. So what's the instantaneous velocity at time t equals to 3 is part B, right? Velocity at t equals to 3. When I say velocity, I mean instantaneous velocity because that's what velocity is. So how do you do this? Well, just like this, v of t is equal to ds dt. What's ds dt? Well, ds dt is, in this problem, 96 minus 32t. I just differentiated 96t minus 16t squared. Did you guys follow me? Yeah, just the power rule and linearity to break it up into 2 pieces, but yeah. And then what's v of 3? Well, I mean, velocity times 3, we just plug in t equal to 3. So 96 minus 32 times 3, which is otherwise known as 0.
So the average acceleration or speed is the same as the velocity, and so you do the same thing as time equals the x value. Is my question making sense?
You know that thing in Star Trek where Spock breaks the computer by feeding it?
I'm not really a Star Trek.
Oh.